understand the competing things tonight. There it is. So I called this the missing link question mark because it might be and it might not be. I want to explore that as we go along. So first, a little bit about me. I've been doing this a long time. I'm in 1969 in BASIC on an ASR 33, if anyone here can remember what that is, or teletype, and it had paper tape. And my program was still old tape, and I wish I still had that.
You can't be that old.
What?
You can't be that old.
I'm on the good tablets. Okay, online since 1982, back in the days of Telnet, FTP, and email, no web, no GUIs, nothing. And my code was then on an 8-inch floppy disk with a massive 128K. Living out acoustic coupler. I really first went online in 1970 when you had acoustic coupler where you dialed the number with a dial phone and put the handset in a box and shut the lid. And you got 304 out of that. I did my first website in 1992 when I was working at the House of Commons, computerizing Hansard and parliamentary questions. And that was just a very few months after Tim Berners-Lee's first website at CERN. 30 years of automate all things because I got fed up with doing things by hand. And I became a big fan of Bash, Shell, and did lots of automation using Bash. DevOps, just before it was called DevOps, I was doing all that kind of CI/CD build pipeline stuff with Bash, just linking together and putting Bash script wrapper, stuff like that. I declare myself here only a semi-fan of microservices for reasons of coupling. Microservices are just tightly coupled things across a network, so it's slower than running it in one system, and you have all the fallacies of network computing to get in your way, and they're very hard to debug. The two big advantages of microservices are they're separate, they can be scaled separately, even though they may not be micro, and you can have separate teams working on separate functionality. Strong advocate of loosely coupled systems, precisely for that reason. When you have a chain of microservices doing steps in a programmatic execution, one of them just backs up. It's tightly coupled. You can't go around it. Big fan of streaming systems. Who here knows or is using Kafka? Kafka is an absolutely brilliant program. It's used by nearly all the Fortune 100 companies now. It originated in LinkedIn when they wrote it to swallow humongous amounts of logs. And I think one of the biggest users of Kafka for an event-driven system is Uber, who have several hundred Kafka clusters running, streaming all the events of make a booking, assign a vehicle, it got there, you got the other end, it's paid, the tip, all that stuff is all done using Kafka queues in an event-driven system, no tight coupling, because you've got the problem of intermittent connectivity with mobile devices. Passionate about real observability. I did a presentation on this a year or so ago. This means not just logs, metrics, and traces, but observability in depth, all the way down your CI/CD DevOps toolchain from code commit, right the way through to running production instances, and beyond, in the sense that you want to keep this for historical audit. You're running a financial transaction system, and your system makes a decision about, should we give Fred some money or should we allow Fred to buy something? You need to keep that as an audit record. The day when somebody comes around knocking on the door and going, oi. And that needs to keep things like which version of the software made that decision. And if you're a really good boy and you're versioning your database, what was the checkpoint of the database on which that decision was made and stuff like that. And because you want to have observability on what you bring in to your system. Transitive dependencies. Maven, I'm looking at you here, that brings in loads of stuff you didn't ask for, but comes in of dependencies of the few things you did ask for. Who remembers the Log4j incident from a couple of years back, where everyone was going, but I'm not running Log4j. Well, without realizing it. And they had to run pen test on their own network to find out where Log4j Jay was running. And lastly, if Fred over there in the corner who never talks to anybody turns out to be a bad actor, I want to know where his code is running on my estate. These are hard questions that most systems don't deal with. Okay. Technology landscape. Agile, don't get me started. Agile has turned into the new kind of open source or internet and gone from pro bono and good idea and cooperation into revenue stream and control. The only two places I ever worked that Agile worked were two startups where you didn't have Jira or Confluence, you had a whiteboard and a rubber, and it worked remarkably well. The only place I worked in a large organization where Agile worked was at the Ministry of Justice, where a very experienced project manager turned up with a box of Post-it notes and crayons, and we used the wall, and it worked better than Jira because it's about the people. Scrum's thankfully dead. That was just an instrument of management control, and this is what's gone wrong. Just because you run Jira doesn't mean you're doing Agile. And what does Agile mean anyway? Agile really means planning for change. Places don't want to do that because it's too complicated and too hard to predict. And you don't need Jira to be Agile, as I've just said. Now, Scrum was the worst example of something that was supposed to be an open, collaborative system turning into an instrument of management control. Well, if all the management wanted was sticky velocity, then they can't be surprised when the developers just gamified the system and upped all the estimates for the tasks in Jira. That way they look good. They got the management off their heads. Okay, DevOps, DevSecOps. DevOps are going to come to in a minute. DevSecOps, that's what we do here. Platform engineering is what we're going to be talking about. SRE is a huge topic. It's always the thing. And it has expanded beyond the keep the lights on to encompass really a lot of what is DevOps and platform engineering has been kind of rolled up into SRE as a job description. When you're looking for a job, one of the amusements is spotting the job descriptions written by the HR department, which consist of a list of random technologies assembled in no order at all, usually not relevant to the role. And observability, which I've mentioned. Okay, DevOps. Now, Roy put a slide up with the definition of DevOps. I'm going to get to mine. It's a lot more than just automated, here's my code, commit, compile, package, test, and deploy. That's continuous integration. Good practice is every code commit should be built right through to an artifact because that will give you your errors. Feedback, that's what you want, feedback. As fast as possible. That's why your DevOps pipeline needs to be fast. It's not on-demand deployment of those tested ready to roll artifacts. That's continuous delivery. Confusingly, that's the other CD, which is continuous deployment, which is run all those together. And high-performing organizations are supposed to do exactly that. Every code commit should be built and deployed right through to production. I did a spell of doing strategic DevOps and architecture stuff at the Met Police. And I had a run-in with some consultant they brought in to review the strategy and all of that. And in his chunky, that saying about if you don't have much to say, make sure you say it at great length. In his chunky report, the phrase that caught my eye was, testing in production, this must never happen. You have to test in production because only production is production. Okay, so what's changed with DevOps? And it's the infrastructure. Because in the beginning, DevOps came before automated infrastructure connection. So we're talking about pre-Amazon AWS. You had pre-existing machinery. It was either your own on premises or it was in a colo somewhere. You were configuring and deploying to pre-existing, immutable, you can't change it, equipment. Then came the cloud, Amazon the first, and what Amazon did was they made it easy. It's still easier than the other ones because to Amazon, the best way to get and keep customers is to make things easy. They patented the one-click purchase and ruthlessly pursued other people who tried to do the same. Make it easy and you'll get the customers and keep them. Then came automated cloud creation, cloud formation. Cloud formation is awful, not as bad as it was to begin with, but it's still awful. But it gave you a way of creating VMs, attaching storage and so on in a scripted way, repeatable, reliable, not sitting there with a mouse. I did a gig at a boutique fintech consultancy in the city some years back. And they called me in to automate the creation of AWS architect infrastructure, an international project, because their staffer didn't want to learn how to do it automatically. He just wanted to sit there with the mouse. And I asked him, why don't you want to learn this? And he went, why should I? What's in it for me? I said, how about keeping your job? This business is moving so fast, you simply cannot behave like that because you're going to be unemployable in 6 months or less. Then came Docker and containers. Docker is a kind of Victorian novel almost. When Docker started, it was a great thing. I found Docker about 3 months after it first began and went to all the early Docker meetups. And with the early Docker, you realized what a very thin shim it was over LXC and LXD that had been in the Linux kernel for years. So the people at Docker were just lucky. They made it simple and they caught a wave, and Docker became a great success, despite Docker's best attempts to shoot themselves in the foot. Docker made so many mistakes commercially. It was like watching a friend die, really, and you were really astonished that Docker managed to survive. And then they started charging for Docker Desktop, and then they were finished, because that's not how it works. And in fact, Kubernetes no longer supports running Docker containers. It only supports running OCI format containers, the Open Container Initiative format. They got rid of the shim to allow you to run Docker containers. And then came Kubernetes and service meshes. Lovely, deliciously complicated, one-line config mistake in your configuration, your network security is blown wide open. Kubernetes is a glorified VM scheduler. Instead of running VMs, you're running containers. Anyone here actually use Kubernetes? I mean, for real. Okay, sympathies. At least now, the Kubernetes ecosystem is growing to a degree of maturity. And not yet say the same about service meshes, which is basically a completely software-defined network. You can do incredibly cute things with software-defined networks. Debugging it is a imprecise science, if I can put it that way. Kubernetes' greatest advantage, and the one that's usually quoted by people when they go, oh, we need to have Kubernetes, is its ability to rapidly scale. AWS gave you the ability to fire up additional VMs when the load was getting high, but VMs take a few minutes to create, fire up, and start up. Kubernetes, you can fire up a whole load of extra containers very fast indeed, provided you've written them properly so that they will do what you start, not the final Java compiling. But it comes at a staggering degree of complexity. You can do very simple Kubernetes stuff with like 10 lines, but to do anything real, you're going into yards of code. Now everything has changed. So what does that mean? It means we need a new definition of DevOps, because it's not, as it was before, just CI/CD through to deploying to pre-existing stuff. DevOps went through a period of extreme hype about 6, 7, 8 years ago, where it was the absolute secret sauce you had to have. And there were a few companies, I won't name them, but they've mostly thankfully disappeared, who were trying to pretend they had a secret sauce for DevOps that was better than anybody else's, and you absolutely had to have it. And by the way, it was rather expensive, but you really need it. And those telling you can't do it without a methodology, I get very annoyed about this. It's the people who go, oh, DevOps is not technology, it's culture. And methodology, of course, is the study of methods. It's not actually a method, but that's just me being pedantic. Noise, a definition that states a new way of working and makes clear how big the changes are, because the biggest change, not just the fact that you're automating it from front to back, top to tail, soup to nuts, whatever phrase you want to use. It's the speed that is the issue. Not just the speed of running those CI/CD pipelines, but the speed that the technology changes. Now, this is a big challenge if you're doing team building. I did, in a couple of my previous engagements, I did quite a lot of recruiting. I hadn't realized before the extent to which people actually flat out lie on their CVs, how they managed to get through an interview. It's the pace of change of technology is the hardest thing. A lot of people are just not happy with that pace of change, like the guy who didn't want to learn automation because he was happy with the mouse. It's a real challenge for people to keep up with learning it. This stuff is changing on a monthly, even a weekly basis, especially in the Kubernetes space. It's really quite scary how much you have to read and learn and keep up with things. So that. And a definition that embraces the tech and the culture. After the kind of tech died down a bit over DevOps, they were all going, oh, it's about the culture, really. Culture, which what they actually meant was agile. And then attempt to conflate agile and DevOps. Bad. Okay, so here's my definition. Tools, techniques, and practices for the rapid, reliable, and repeatable. Those are the three most important words in that sentence. You want it to be rapid. Why? Not just to get to production deployment faster, but to provide fast feedback to the developers, because the core purpose of DevOps is improving code quality by giving you fast feedback to the developers. Not hoarding changes until 3 o'clock on a Friday, pushing deploy and going down the pub, but doing it every time you commit a change set, because you want that feedback early, because the sooner you get the feedback, the easier it is to fix, because you're not so far away from the bug. Think Accelerate. Who's read the book? Accelerate, Nicole Forsgren and ubiquitous Gene Kim and Jez Humboldt of the Jez and Dave Roadshow. It's the book that they did, academic research about companies to find out the difference between high-performing software companies and low-performing software companies. How to get to that high performance. And it's all about accelerate, making this stuff run faster. So automated tests, security procedures. I'm not going to go into security today. This is the DevSecOps group because I'm talking about too wide a field. And observability is I've been going on and code quality being a thing. So that's DevOps. Now, that infrastructure, back in the days of the bare metal, you can't automate the creation of the bare metal. You have to fill out a form and ask IT department to buy one, stick memory chips in it, put an operating system on it, and tell you when it's ready. Cloud, VM, and container creation can be automated. That's the whole point. And it should be automated. I'm going back to the bloke who didn't want to automate it because he wanted to do it with the mouse, because it's not repeatable and it's not reliable. Because the idea of this is that this stuff during development is disposable. You fire it up, run the test. If it doesn't work, you throw it away and make a new one because it's clean. You know its starting point. The automation of CI/CD ran ahead of the automation of infrastructure because there were no hardware dependencies, just target machines. So that is the origin point of platform engineering. In the CI/CD pipeline from code commit to running instance, there came a bit where you had to create the stuff you were going to run it on, whether it was a VM, a container runtime, or Kubernetes, which is the glorified container runtime. You had to create it and then deploy into it. And infrastructure automation became more and more complicated. Kubernetes, I'm looking at you here. It became an even bigger and bigger part of the DevOps pipeline until eventually it grew into a separate field of its own. So you have platform engineering people who are dealing with the creation of the infrastructure, the DevOps team to deploy into. Okay, so for example, toolchain differences here. DevOps uses Ansible, containers, platform engineering, Terraform, and Kubernetes. Now, Terraform and Ansible are the two most popular automation tools for doing this, but they're quite radically different in how they work. Ansible is brilliant for creating and configuring databases, disks, whatever. but it doesn't retain state. Ansible is brilliant for creating things, but it's rubbish at destroying things. This is no good when you want to have the immutable infrastructure, make stuff, delete it, throw it away, make another one. Where Terraform maintains the state of what you've created. So when you make a change to the specification, it will look to see what change you've made and apply just the change to that stored state. And you can delete the whole thing. It knows what you made, so it knows what to delete. Now, they are configured similarly. You're using YAML or HQL, which is a kind of bastardized compromise between YAML and JSON. But the structuring, the techniques are very different. The way you structure the code in your code base are very different between them. And switching between them is a big cognitive load. Now, this is something that's emerged in recent years, the question about the cognitive load on developers, DevOps people, and the platform engineers. This stuff is getting sufficiently complicated that the cognitive burden is something to be considered. It's not helped by people who like to write fancy code with lots and lots of modules and so on, which makes it very hard to follow the sequence of operations and the concept of what you're trying to do. This is, who's read Team Topologies? The book by Matt Skelton and Manuel Pace. I know Matt Skelton, he's a great guy, and I'm so happy for his success. It's about how you organize teams for high performance. And one of the most important things is the cognitive load, because the cognitive load slows people down and makes them stressed. So, a definition of platform engineering. Is it part of DevOps, or is DevOps part of platform engineering? As we put on the intro slide. Or are they separate disciplines? Well, they're certainly separate disciplines from the point of view the way you do them and the code you write them in, and the way you structure that code are significantly, and in some cases dramatically, different. But they're linked because you're going to have your DevOps toolchain, call it platform engineering toolchain, and then go back to a DevOps toolchain. So they have to be linked and interoperable. Revolving into two separate disciplines, but for how long? You know, the tendency for things to kind of merge together. Well, there's an anti-pattern here that you have to be wary of. You take people out of the DevOps chain to turn them into platform engineers. So you're now losing their skill from the DevOps tool chain. And the people in the DevOps tool chain left are going to work harder. You've turned it into a kind of shadow IT operation, which is not good. Shadow IT is seldom good. And the blurred boundary between them, this is not like the old Dev and Ops, you know, hard boundary, throw it over the wall and you're not allowed into the ops room because it's got a combination lock on the door. That was a good blunting of productivity, wasn't it? And increased cognitive load, so productivity suffers. When in doubt, create another abstraction layer. Internal developer platforms. So internal developer platforms are your rolling platform engineering and DevOps all into one thing to make a one-stop shop self-service for the developers. Now, this brings two important benefits. One, it's easy, so it's like AWS. You make it easy because the best way to get people to do the right thing is to make it the easiest thing. Otherwise, they just find workarounds. Developers are like herding cats. You all know this. They all have their little secret tricks that they like to use and not share. And you can fill it with templates. So you choose, I want this kind of build and deploy or that kind of build and deploy. They're not making it up as they go along. This gives you much better consistency and of course helps with security because you have deterministic architectures and connections that you can apply defined security to. And it rolls in, hopefully, all the tiresome stuff. Variables. Variables is still a huge issue. Variable inheritance and so on, and it's one of the commonest reasons of getting into a muddle with your infrastructure and DevOps code. It's often referred to as the paved road. In other words, it's the easy highway from code commit through to running production instances. And of course, I would add pervasive observability, including what they said to begin with. from code commit to running and beyond, and everything in between. Okay, so it employs both platform engineering and DevOps. So the nomenclature gets a bit fuzzy here. Team topologies talks of 4 kinds of team, one of which is the platform team, providing the compelling platform to accelerate the delivery by streamlined teams. That's an IDP, although the book doesn't call it. It's clearly what it refers to or what satisfies that requirement. So platform engineering has eaten the world because it's now become bigger than the DevOps bit, because creating the infrastructure and getting rid of it and all that kind of thing is more important. And it comes the engineering of the internal developer platform. So we need a new job title. Dev platform engineering 2.0, have an IDP engineer or what. So platform engineering, they're complicated. Anyone here played with Backstage and tried to make it work? Yes. It is furiously complicated. There are others coming along. The one it always makes me smile is Pulumi, where instead of writing in declarative YAML, you can use the programming language you're using for your applications instead. I love the idea of trying to debug that stuff. We use developers all writing in different languages, doing the infrastructure code. Conceptually, everything is created an on-demand target environment to give you this immutable infrastructure. We're deploying stuff to lots more places than we used to. It's not just the server room or AWS's server room, which may be a lot bigger than yours, but it's still just a server room. You have serverless, which of course is a lie, a bit like big data, which is also a lie. Edge and WASM. Now, who here knows about WASM? WebAssembly language. WebAssembly language is a language that compares to something you can run anywhere, in your browser, on a server, or scariest of all, in network nodes on your service mesh. This is fabulously cute, but how the hell do you debug that? I don't know, and I haven't met anyone who does. So it's the paved road, but with knobs on, it's paved with gold now. And of course, it's got to include the SRE stuff, depending on what you think SRE includes. So what we got to is we've got to one moderately complicated thing that then generated the need for a more complicated thing, now rolled together into an even more complicated thing. So DevOps and platform engineering will disappear as separate skills in part of platform engineering 2.0. IDP capable platform engineers become the new gold dust. I'm one already. I'm going to put it on my CV right now. Change rocks. Start with my CV. Thank you. This is the reading list. This is the book I was talking about. This book is the book you give to your managers. You give them and ask them to read it. And they go, I don't understand. You go back and read it again until you do understand. This book is all about how you achieve high-performing organization by improving the speed of that pipeline. Speed because you want fast feedback, early feedback for the developers to catch bugs early. The cost of fixing a bug in production is a lot more than fixing it before it gets anywhere near test. You also want it because you want the ability to roll out change fast. You do find a bug and you want to get it through to production quickly, you need that tool chain to move fast. This is the team topologies book. Let's go. Manual pace. So this book, in fact, tells you how to organize your teams and work practices in order to meet the requirements set in here. So those 2 books are absolute required reading. Both on Amazon, they're not a huge amount of money, but they're superb books. This one is the Site Reliability Thick book I told you about, which is a wealth of wisdom from Google about error budgets, all that kind of thing, how to think about reliability as a skill and discipline in its own right. It's not an easy read. It's a big book and it's complex, but it is an important one. And then this one, because I'm the observability fan. This one is more recent book, Charity Majors and Liz Fong from Honeycomb. Who knows of Charity Majors and reads her stuff? Charity Majors she's American. She's little, she's squeaky, covered in tattoos, usually with blue hair, absolutely foul-mouthed, which had to tone it down a bit now. Honeycomb is going for an IPO, I think. But she's seriously smart. And if you read her blog, charity.wtf, there's a lot of smart stuff in there about observability and how most people are not doing it right at all. That's it. Thank you. Maybe some time for questions.
Okay, thank you. Okay, so any questions in the room while I just see whether we've got any online?
Or can I go and catch the rest of the match?
But first of all, thank you so much. And what was good was it was and Andrew, as you can see, he's got a certain style. He's not going to sit on the fence, as you can see, yeah, which is great. It's good to have views. It's good to have opinions, because I think that's what we want, isn't it? We want to have viewpoints. So thank you for your honesty and your viewpoints. So any thoughts in the room? Anyone want to challenge Andrew about any of his views or viewpoints? Because I think that's good sometimes. Yeah.
You mentioned the speed of technological change
Yes.
being one of the big challenges. What are your thoughts on whether it's change for the sake of change or actual productive change?
There's those two, and there's a third one, which is simply because it can. You know that aphorism, no computer program is ever finished. Well, an application program may get kind of asymptotically close to being finished, but this stuff, there's always, oh, we can add this, oh, we can add that. And it's either, people coming up with bright ideas, or it's a company looking to create a product that they can monetize. And the pace of change is as much a result of that and the core immaturity of these technologies. VM's been around a long time, and it's just someone else's hardware. VMs are fairly predictable. The networking is the issue there, but the VMs themselves are fairly predictable. Kubernetes is a lot less predictable, and it's a lot more complicated. And there are lots of kind of hidden things in Kubernetes because so much of where your code is running is hidden and not modifiable. Networking on VMs is networking in VM servers is a black box. You can neither instrument nor control. You have even more of stuff you can't instrument or control when you're running something like Kubernetes. And service meshes, like I say, the ecosystem is just too immature. I mean, it's huge fun in test environments to do things like progressive canary and all that kind of thing that you can do with service meshes. But I would not feel comfortable running a service mesh in a production environment yet. There are also new developments coming along with that. eBPF, which is, who knows about eBPF? Yeah, you're talking next time. eBPF is an astonishing technology. It's another thing that existed in the Linux kernel for a long time, enhanced Barclay packet filters, but it's a complete misnomer. What it is it's a brilliant and very fast networking. You can do overlay networks like Cilium running eBPF, which, again, wonderful technology. Can do brilliant things. This is all the stuff of changing so fast. Right down to the network layer. It's not just top pipeline layer that's changing fast. It's all the way down because Unix originally and then Linux was so brilliantly designed. You have to look back at the people who did those early designs. Brian Koenig and Dennis Ritchie on Unix. And the people who designed Ethernet and TCP/IP, who even in their wildest dreams would never ever have imagined how big its scale, yet it bloody works. And Unix has that, Unix, Linux, because everything is, in kernel and everything's a file and all that kind of thing, it's incredibly flexible. And people have been able to devise the most astonishing things that, again, the original creators of Unix would never have thought of. It's often rather cruelly said Unix came along as to be something better than, what ran on a VAX cluster. But it got away from that because it did so much more those early operating systems did, that were just really organizing the data going in and out of the applications out to I/O or storage or printers or whatever. But Unix could do so much more. When I first started using Unix 35 years ago, I was absolutely flabbergasted with the fact that I could be working on one machine and I could, do something, produce an output and send it to a printer on the other machine over there, or to the tape drive on that machine over there. Couldn't do that with PC, with Microsoft. You still can't do that with Microsoft, because Microsoft is not a multi-user, multitasking operating system. And that flexibility has what's enabled Linux to keep going and keep going and keep going. And no operating system that's emerged since has beaten it. There's no point in having another one because Linux does it all. Most of the big problems in Linux seem to have been finally wrung out because what you're looking at is a 45-year history since Bell Labs first created Unix. So it's a well wrung out system. Most of the big bugs have been got out of it because the fundamental architecture hasn't changed. So the world runs on this now, and it stays running. So that is every layer. You have that flexibility to do new things, and that, of course, is contributing to that pace of change because it can be. And you've got people coming up with brilliant ideas all the time. And some really, really interesting stuff kicking around at the moment, especially to do with networked and distributed systems, Kafka being one of them. Ceph, who knows about Ceph? CEPH? You? What? No? Ceph is a distributed file system, another open source project, CEPH. Which is astonishingly powerful. It needs some quite meaty processors to keep up with it, but it's very, very interesting. And whole loads of other things like Cilium, based on eBPF, emerging out of the woodwork and coming out of, look at all the stuff that's coming out of the Apache Foundation. I mean, there's 150 projects in there now, Kafka's one of them. There's some fantastically good stuff in Iceberg. Apache project. Who knows about Iceberg? Yes, code. Okay, Iceberg is a database table format that allows you to have distributed systems, and it's beating Snowflake. Well, who'd want Snowflake? Yeah. And these open source projects that are going into CNCF, Apache Foundation, are now what's shaping the future. You're seeing less and less dominance, even less and less penetration by proprietary solution. What you're seeing is instead monetization by providing support of open source systems that you can run free to play with. That's another great thing to help adoption. Hey, this is really cool. Can I play with it without having to get out? I go and ask for a purchase order. Yes, I can. Then I can go to the boss and go, this is fabulous. Give me money. We want to do this. That model, Red Hat kind of a bit lost its way. This one, get rid of CentOS. You've got things to fall back on like Alma, but they kind of broke the spirit of being the open source company that you can then pay money to for support and extra reliability, whatever, SE Linux, all those kind of things. We had the Elasticsearch business, and people going to more restrictive licenses. HashiCorp, for example, over Terraform, that really pissed off the community. How far Open Tofu goes, we'll wait and see. Apparently, they've already added a feature that Terraform, encryption of state files, that's it. They've added encryption of the state files because you want to store those on the network so that all the infrastructure developers can get at them. And I met Mitchell Hashimoto. He seems like a nice guy. They have made a few mistakes. They tried to create an an alternative to Vagrant, because Vagrant was written in rubbish language. And they tried to create an alternative written in Go, because all their other stuff is written in Go, but they had to abandon that. Vault is a great product, if only if it was a bit easier to use. You always end up, if you're in the cloud environment, having to have it work with the cloud vendor's secret store as well, which again kind of reduces the ease of operation and ease of use. So some change is good, some change is bad. Who's surprised? That's life. Your cars have the same problem. Sorry, I went on a bit, but you know, you were the only question. So, the troublemaker at the back, yes.
So, these are good questions that auditors need to ask.
Sorry, I'm coming to hear you.
Oh, okay, what are some good questions or necessary questions that auditors need to ask when they're seeing all this rapid change?
What kind of auditors?
What questions?
What kind of auditors?
Okay, good question.
This is why I'm a fan of these the streaming system like Kafka, because unlike a message queuing system like AMQP or RabbitMQ, where you put a message into an opaque pipe that's then pushed out to the target recipients and then disappears, Kafka's model is different. The pipe is transparent. You can run SQL queries over the stream. And the recipients are pull listeners, not push. And once every recipient has pulled the information they asked for and decided what to do with it, it remains in the stream unless you actively get rid of it based on time retention or you've run out of disk. But you can filter that and keep those audit records as long as compliance asks you to do so. And all of those can be about software updates, even operating system updates, all the kind of thing that you might want to be able to go, right, at that point in time, 3.5 months ago, what were we doing? Because something messed up. And something messed up in a way, not to stop the systems working, but ended up producing wrong information or questionable decisions or whatever. That's why you need the audit trail, not for stuff that's going to happen tomorrow because you screwed up today, but stuff that appears downstream later, especially the stuff about imported dependencies and questionable people. You need that a long time because you may have to look for trends and patterns. I'm very curious about the opportunities for running AI across such an audit trail streams. Because I think it could produce some very interesting results. Of course, AI is super fashionable. There's AI everywhere. An amusing story about AI for random reasons. Earlier this year, I went to the hotel and restaurant catering equipment show out at the Excel, where a manufacturer of ovens was going, we have AI. Okay, how does that work? Well, we have a camera over the door. So when you put in the tray of croissants, it recognizes croissants, and we set the timer for that. Right. So, you know, AI has come down to the most ridiculous levels of nonsenses. The other thing I get very cross about is politicians wanting to restrict the development of AI in this country because they're worried about people generating pictures of Rishi doing unspeakable things or Taylor Swift with knickers or something. That is not the important issue. But as always, when a cry of something must be done goes up, you can absolutely positively guarantee the politicians will do the wrong thing. What is the number one reason why we should not restrict the development of AI in this country? Answers, please.
Because others are developing it anyway.
Sorry?
Because others are developing it anyway.
No, but that's not.
They will lag behind.
No, the most important reason is because our adversaries of all kinds will not. They will go on developing AI. And the number one most important reason for having top quality AI is to detect when those adversaries are using it. Right now, the AI is kind of fairly obvious. In 6 months, it'll be less obvious. In 2 or 3 years, it'll be very hard for human detection, both textual and image. The perversion of the image space, the perversion of the information space is the thing to be most worried about. Not cyber attacks stopping the power station working. That's inconvenient, but obvious. Subtle stuff is modifying the information on which the AI you are using bases its decisions. You pollute the information spaces that are imported by the AI to skew the results. It's bad enough that AI systems don't give you a consistent answer to the same question because they have opinions, because that's what you buy them for. But that, and you had the people who were commercial information providers going, "Oi, we don't like you taking our expensively created commercial information and sucking it into your AI models. Fine, you have to pay." Right, result, the AI engine stopped sucking in that high quality information and suck in the open source, freely available information. Now you've just given the people with enough motivation and enough resources, the targets to go after, to modify, skew the information, the AI decisions you're going to get. Because generative AI, is cute, but the really important AI is the AI where you ask questions of an information set. And information sets that are changing quickly. So what you've done is you've reduced the amount of information available, which makes it easier for you to pollute what's there. This is what all the politicians are missing. Sorry, that's a bit of a soapbox, and this was kind of our topic, but
That's okay. So we take one more in the room. I've got a couple of questions online. If
Back to your containers.
yes,
When you get containers, how you scrutinize them for bad code or bad industry code like log4j? And it is not just one-off, because once you start containerize, you keep on downloading updates and upgrades. So in an organization, you may have hundreds coming
Sure.
up
well,
on daily basis.
at a simplistic level, a container you can think of as just being a micro VM.
Yes.
It's layers. I mean, a container archive format is basically just a tar file. So you've got the various layers in there. They could be the application code. So you can do things like you can unpack that container, strip off the lower layers, replace them with ones you know are good, repackage it, and then put it into your archive repository. This is what the US military do on their Platform 1 container registry, so that they know that no bad level code is getting packaged in with an application, because you replace it with ones you verified yourself. So beyond that, containers are just fast
That will break
disposable.
most of the applications.
Sorry?
That will break most of the applications.
Yeah.
For example, if I download Elastic,
Most applications nowadays are less than 10% original code. You're basically just writing configuration on top of functional libraries. This is the problem about the imported dependencies.
yeah,
That's all
for
you're
example,
doing.
if you download Elastic, that also have an underlying Linux code. Elastic container will have some sort of OS underneath it.
You have to have a container runtime, yes,
Yeah, and a lot of upgrades apply to that code.
and to the container runtime.
Yeah. If we replace them, we will lose those upgrades. So we will not have the recent upgrades.
But that's,
And-
how is that any different from upgrading an operating system, a machine hypervisor? Actually, there's no difference.
When we get a OS upgrade, we get from Microsoft.
Uh-huh.
But now we are getting a container from Elastic. Elastic may be trustable, but sometimes you are getting from not that trustable container. Does that make sense? Or?
Yeah, but the base image would be something like Debian or Ubuntu.
Or Alpine.
Alpine,
Alpine is the
yeah.
most popular one
But
for a small
For
footprint.
me, to differentiate, if I download, for example, Elastic container that have a base image,
Yeah.
how can I make sure that base image is authentic? It has not been altered.
We're talking about SBOMs here.
Yeah.
Software bill of materials. Yes, you need idents for all the layers, just as you need idents for all the libraries you pulled into your application code. SBOMs now mandated, aren't they, in America?
That's right, by Biden executive order, and hopefully we'll get them in the UK as well.
CISA, Cybersecurity and
Infrastructure
Security Agency, which partners with NCSC here on this stuff. I'd like to see NCSC being a little more proactive about this. It was disappointing when they went from providing advice to providing only guidelines. That left things a bit too vague. All the things that need fixing all the time, and it's hard. That's another. The malware is changing at rapid speed as well, not just your tool chains.
Can I bring it back to the
Yes,
the
of
platform
course.
side? So thank you for the questions, by the way, about containers, and I think that is a really challenging area. But just thinking about the platform side, we've got a question here, which is, would Andrew comment on what strategies DevSecOps teams can implement to ensure continuous security integration without significantly impacting the speed of the development lifecycle in the context of emerging technologies like AI, ML, IoT? So a lot in there, but it's around, what are the strategies that DevSecOps teams can take in this world which is continually changing? And we've got platform engineering. How can that help?
Automate all the things, but you have to update what you deploy and configure as security components and parameters all the time.
So it's taking the medicine.
Absolutely.
Yeah. So
You have to, and that part of your deployment is going to change faster than your application code because you're constantly having to check the CVEs. And of course, CVE checking is not just a build time activity. You don't want alerts just when you're pulling in a whole raft of Maven dependencies. You've got to go on checking that binary because the exploit may be discovered weeks or months after you've built and archived that artifact. You have to check it against all your deployable artifacts on a regular basis, a minimum daily.
Yeah. Okay. What I'm going to suggest is, has anyone else got a burning question they want to ask in the room? We have one more.
What's the score?
Yeah. Yeah, and then we'll call it a.
I can't agree anymore that everything you say in the slide. Just one doubt about
Okay, hey, only one. I did well.
that you prefer not to run service mesh in production. So one of the challenge I have is, I mean, I'm a big fan of event-driven architecture, but not all the workloads suitable for this asynchronous communication. So inevitably, we need inter-service communication, and managed certification. Certification is the biggest challenge. Without any service mesh, then all the teams, all the microservice or service need to manage their own certificate. So
But the service mesh is only providing a programmable connectivity layer between your microservices or your streaming queues.
So I'm using
And probably it runs slower than just direct.
I'm using a context like, for example, Istio or Istio example, right? You have a sidecar, you intercept traffic, you do MTLS between the service, you ensure that the communication is secure between two services.
Sidecar proxy, yeah, those are kind of going out of fashion now, though, aren't they?
So there's like API and then
What's that one? What's the one that's sidecarless? I can't remember the name. Begins with an A.
LinkedIn. No,
I
LinkedIn.
can't remember, so I'm not going to invent. So there are ways. Sidecar is just one early solution. There's ways of doing this. What you want to do is you want to be able to control everything goes in and out of a container or a microservice instance, and do things with it. That could be security, it could be logging, it could be traces, it could be all kinds of things. The service mesh just gives you that great programmability of being able to do stuff with this. And the scary bit about running code in a service mesh node. But my worry about service meshes is mainly around making them, because the ecosystem is just not mature enough yet. Let's face it, they're complicated. The man page is terrifying. But it is a beautiful and brilliant technology. We'll get there. We'll get there until the next big thing comes. Maybe service meshes will die a death and we'll do it all using eBPF and Cilium or zero trust mesh networks. Because service meshes don't inherently give you security. You've got to write that in. They give you connectivity. If you want security, you've got to write that in. And if you want encryption, you've got to write that in. It's just programmable connectivity. But the zero trust is at last starting to become widely available and usable, because I have for years felt that VPNs were the next accident waiting to happen, and so it's been proven. Because VPNs are just like a firewall. You know, it's hard shell, soft center. Once you penetrate the firewall, you're into everything. Once you penetrate the VPN, you're into everything. Everything that's on the internal network. And you go, you know, horizontal traverse and scanning and looking for open things. Zero Trust stops that. And Zero Trust Mesh is a very elegant way of connecting all your microservices, whatever's together. I cannot remember, or I did not yet read whether you can do ZTM over a service mesh, but I'm sure you will be able to soon now. Yeah.
Go ahead, Sam.
Just a quick one, Andrew. You mentioned internal developer platforms, which I think are very important. But I think it's just Backstage that you mentioned, which is open source from Spotify, I believe.
Yes.
Is there anything else?
There are some others around. I can't remember the name because I haven't looked at this topic for a bit. There'll be more. There'll be competitors in this because it's an opportunity. So there will be entrance into this space. And please, something a little simpler than Backstage.
One you might want to look at is Kratix.
Yes.
That's a relatively new one.
Yeah.
Different to Backstage in how it works, but you know there are some out there.
Yeah. They're coming along.
Yeah.
It's very much an emerging field on service meshes.
Yeah. Okay, so I'm going to wind it up at this point. So thank you so much. We've had some really good feedback, Andrew, online. So I can show you some of that later on. But one of these here, which summarises it really well, is two comments, by the way. One was superb use of time in terms of packing so much information in. Yeah. Again here, thank you, Andrew, for such accessible and useful definitions. And this is somebody who says they're speaking as a CompTIA grunt. So there we go. So the definitions of terms was well appreciated, good use of time, and everything else that went with it. So thank you very much again. So thanks very much.